This lesson continues yesterday's idea about comparing the size of the product to the size of the factors. In this first problem, we're looking at three different ideas. We have 2 meters multiplied by 97 1/100ths. We have 2 meters times 101 1/100ths. And we have 2 meters times 100 1/100ths. And the idea within this specific lesson is not to solve the problems. The idea is looking at it and looking at what we're going to call the scaling factor, which is what you're multiplying it by, in this case, the hundredths, and seeing if it is greater or less than what you're starting with. Okay, so you look at something like 2 meters times 97 1/100ths, and for me, it's easier to look at it as a decimal. So I'm going to write all three as decimals. Okay, so I've written these out in decimal form, and just looking at it, it's easier to see where the numbers are in relationship to 1. And we have the one here in blue written as a base, so that we're able to compare and contrast, well, more compare, where these are going to go. Okay, so if I put them in order from least to greatest, I'm going to have 2 times 97 hundredths, and then 2 meters times 1, and then 2 meters times 1 and 1/100th. Okay, and the reason that I know that is because I'm looking at the scaling factor, in this case 1 97 hundredths and 100 1/100ths. The big idea that we want to get through with this is that if we're looking for a product that is less than the starting number, in this case 2 meters, we want to multiply it by a scaling factor less than 1, in this case 97 1/100ths. However, if you want a product that is greater than the starting number, multiply the scaling factor that is greater than 1, in this case 1 and 1/100th. It doesn't matter that it's only 1/100th greater than 1. Okay, it's greater than 1, so you're going to end up with a number larger than 2 meters in this case. Take a look at this problem. 19 4/10ths multiplied by 96 hundredths and 19 4/10ths multiplied by 2 1/100ths. Which is going to be greater, and is it going to be a little bit larger, or is it going to be significantly larger? For a problem like this, you can order it pretty easily in your head just by looking at the numbers to see 96 hundredths versus 2 hundredths. If you want to show your work, you can subtract it out, but you don't have to. I'm going to assume that you know that 96 hundredths is greater than 2 hundredths. Okay? Where that gets a little bit trickier is when we mix in whole numbers. If it helps you, use your place value chart, and then you can write in the numbers as you go. For this problem, we're going to say that 19 4/10ths is significantly larger than 19 4/10ths times 2 hundredths. A lot of that depends upon, however, what sort of scale you're working with and what numbers you're working with. Okay, take this next problem as another example, where we have 1 2 hundredths times 1 73 hundredths versus 29 1/100th multiplied by 1 73 hundredths. Go ahead and solve those and determine which you think is greater. Also consider, will your solution, will your product be greater than 1 73 hundredths, or will it be less than, or will it be the same as? Without solving these, we can see that the first set of numbers that we're given are going to be slightly greater than 1, because we have 1 2 hundredths times 1 73 hundredths. If I were to round it, I would say it's 1 times 2, just rounding to the nearest whole number, so it is slightly greater than 1. Whereas 29 1/100ths times 1 73 hundredths is significantly greater than 1. I would round 29 1/100th to 29 and this to 2. Okay, and then multiplying 29 times 2, I'm getting 58, which is much greater than 2. So I want you to be able to look at those and go, are they greater than 1? Are they less than 1? And how much so? This is going to help as you're estimating and seeing if your solutions are reasonable.